It is not capturing the edges. So now let's fix this. Now let's adjust this window. Okay, so here my scan lizard is being captured.
Hello everyone, my name is Piyush. Welcome back to the channel. In this video, I have made a document scanner using OpenCV. To find out how this works, watch the video till the end.
So on the first day, I've created the virtual environment in the week2 folder, then named the file scanner.py, then imported the CV2 and the numpy function, and after that I've imported using the ingredient function the images. Now I've resized the image to a standard height of 800 pixels. So first I've calculated the height and width of the image, then the scale factor, and then resize the image. After the resizing is done, I have printed the image and then loaded the image calling the function reprocess image, copying the path to the image. Then let's hit the run button, and as you can see the image is being resized. Now as the image was in BGR, I have converted this to grayscale for the better understanding of the CV. Now we can see that grayscale is being done. The images earlier was in BGR, now it is done converted to the grayscale. But still there are some noise. We have to remove the noise from the image. Now after applying the Gaussian blur, which smooth out the noise and the text details. So it create a kernel of 5x5 size. It covers 25 pixels at a time, and 0 lets the OpenCV to calculate the standard deviation automatically. Okay, now after doing the Gaussian blur, as you can see that the blurred image is there. Now we have to just use the Canny Edge Detection tool to detect the edges of the images. Now as I have applied the Canny Edge Detection tool, so 200 is the highest value that it applies. So any edges after there, the different color is applied. So it detects edges and give the value 200. So where the value is 200, there are some edges, and where the values are 75, it classifies at the part of the edge. Okay, so I've done this Canny Edge Detection tool, and after clicking the run button, okay, now the edges is being detected. But as you can see, the notebook was in spiral, so here the blacks were there. So the blacks were greater here, so it was some difficulty for the tool to classify them. So it is some of the limitation of the tool. The reflection of the white color is high, so it was not able to detect that here is the paper leaks. Coming to the next step, we have added the contour. What it does is finding the object in the image. This list function, it tells the OpenCV to retrieve all the shapes without worrying about its size or how the image is placed inside another image. Then the chain approx sample function, it does the approximation of the pixels. Like if in a straight line there are 1000 pixels, so it considers the starting pixels and the ending pixels and join them to form a straight line. So it does the space management. Now here we have saved the contours and arranged them from the biggest to smallest. So here the reverse function does that, and it keeps the top 5 of the biggest image. As we can see in the document scanner, the page is the largest object, so we have to find the page. Now I will loop over the largest 5 shape that we have collected, and we will smoothen out the images. To a human eye, the image appears to be bumpy or canny. It smoothen out the image using the Douglas picker principle. So we have taken the 2% margin of error in image. The paper is there, so paper has 4 corners, so if the corners are 4, then document contour equals to approx. So earlier we have set the document contour to none, and if it is not none, there is a contour in the image. So we have created the copy of the resized image, then draw the contour on the image, which is of green color and thickness to be 3 pixels. Then we have printed the image, set the weight to 0 and destroy the windows. And after that, return the document contour of the function. Then we have taken the else statement. If the print could not find a document, try adjusting the lighting and return none. So now we have done this thing to include the code of the function in different projects too. Next is we have defined the path of the image and run the pre-processing function and then the contour function. Now let's run the image. Could not find a document, try adjusting the lighting. So the problem I did was the image that I uploaded has a spiral binding. So instead of taking the 4 corners, it think the corner to be 40 around. And the spiral bindings has so many rigid edges. So now I have just replaced the image to another image. The image green corner is being selected. We have made the contour in the image, finding the edges and drawing a green rectangle. So now the problem was if the image is skewed. So to solve this, we have to make a transformation function. So now I've created a function which take the points. I have made a rectangle which creates a numpy array of 4 points, which is top left, top right, bottom right and bottom left. Then I have taken the sum. The smallest sum of the point will be the top left point and the largest sum will be the bottom right point. Similarly, we have the difference. So the top right will have the smallest difference, as we can see. The bottom left will have the largest difference. So now I have created a warp document function, flatten the angled image, that if the image is taken at an angle, it would look like a trapezium, more of diamond. So to solve this problem, I have created the warp document function. So by using the distance formula, I have calculated the width of A and width of B. We have taken the maximum width similarly and the maximum height. Then we have make a flat destination image which take the top left point, which is the 0, 0, then the perfect top right and bottom left points. Then we have make a transformation matrix which carries the values of the, and now I will put the image path, then using the function to show the final image. Now let's run the function. As you can see, here is the image with the green corners finding the contour of the image. Now the final scanned image, which is the part of the green image. Now I've made the scanner available to the webcam. Now the functions were the same as the scanner.py file. This thing I have initialized the webcam using the cd.video capture and have created a loop which carries the rectangle and the frame. After resizing the frame and using the functions that I've created above. Let's run the function. So here is it. It is not capturing the edges. So now let's fix this. So now as my webcam was a bit too laggy and it was not capturing the A4 size sheet, so therefore I used my webcam of my phone. So to enable it, I downloaded a IP Webcam app and pasted the URL. Then there was a lag. To eliminate the lag, I increased the buffer size to 1. Then the video loop capturing from the phone webcam and the same things like earlier. So first, in order to record this, I have to start the server from my phone. So after starting it from my phone, I have to paste the URL that I am getting from the phone, like it is from here. So now I have to click the start button. Now let's adjust this window. Okay, so here my scan result is being captured, and as you can see from the fraction of the second, the green line appeared on the screen and it just captured the white sheet. Now let's push it to GitHub. Now let's open the GitHub. Okay, now here week 1 is added and then here is week 2. So that is it for the video. Stay tuned for next project and thanks for watching.